right, so in order for us to start talking about public and private goods, we really need to start talking about, we have to make some more definitions here. So one of the definitions that we're going to talk about is what's called rivalry. And so rivalry is this notion where goods are bought and consumed by one person, and as a result, those goods are not available for another person to buy and consume. So let's think about goods that are rival compared to goods that are non-rival. So what would an example of a rival good be? Land? Pizza? I mean, your seat in this class, right? There's a limited amount of seats in class. This class isn't full, but the other one near full. Online ones get full a lot. So those are definitely rival. What about some non-rival things? So non-rival things are all the digital goods, right? That were, so apps, music, videos, just anything that somebody else consuming doesn't take away from your ability to consume it. So, the other thing that's non-rival is, the air. Or, national defense. So it's the notion that one more person enjoying it is not going to take away from one other person enjoying it. So with rival, it's this kind of zero-sum game, right? There's only so much, so if you consume some of it, that's less that other people can consume, right? So this would also be, something like concert tickets. But a non-rival good would be something like e-tickets, right? For like a live stream. They can sell as many of those as they want. Selling one more of those e-tickets for a live stream does not take a place or does not decrease the total amount or total supply of tickets that are available. So that's rivalry. Any questions on rivalry? Okay, cool. So the other definition that we have to learn is excludability. And so this is the notion that sellers can keep those who don't pay for a good from obtaining its benefits. So again, let's think about some excludable versus non-excludable goods. So an excludable good, so the seller can keep those who don't pay from a good from obtaining its benefits. So concert tickets, right? You can't get into the concert without a concert ticket. What else is excludable? So the one that we talk about a lot is country clubs. Those are excludable by definition. Let's talk about some non-excludable things. Maybe that'll help. Yeah, but they'll track you, and they'll, like, if you do it too many times, they'll start to ding you for too many IP addresses or something, right? So you're like, I haven't been dinged at all yet. So yeah, so non-excludable. I mean, yeah, I would say that. I'd say login infos for streaming services. And that's a big reason why Scarlett Johansson, sued Disney over the Black Widow movie, is the fact that, she would have had all these box office sales if they would have postponed, which a lot of movies have done. They've been postponing, just hoping for everything to go back to normal so that they can start getting, because, I mean, again, we talked about this before. They make billions of dollars off these movies, both domestically and internationally. They're a huge export of the U.S. economy, right? And so by having them streamed and then having them super easily pirated and put on Pirate Bay or whatever, right? It ends up being a large loss for both the company and for the actors and stuff who are sometimes paid a percentage of the box office as well as part of their contract. So I'm sure that they will settle, though, because it doesn't look good for all these.
Well, they're doing with the other movie too, the 10 Rings movie. That actor is also getting really upset about it because they were using him as an experiment, so he's also trying to go against Disney. So it's like multiple actors now, so I don't think Disney's gonna be able to just get out of it anymore.
Huh? But they only released that in the theaters. They didn't release it streaming.
They released it in theaters, but they were talking about it as seeing if they can get more at box office or streaming. Like those were the two movies that they're testing out their theory with of what they're going to do in the future.
Oh, well, I mean. Oh, yeah. I mean, that's a big corporation for you. They can do that kind of. It's literally A/B testing. Like it has like names and data science and other kind of stuff, right? So I mean, it seems like it would be obvious that the box office would make more sense, but yeah, and that's what we're seeing. But I mean, I guess you can't beat real numbers at the end of the day, right? So other non-excludable services. So, one of the ones we mentioned up here, that non-rival service, right? National defense. We can't, you like if you're not an American citizen, but you're here in the United States, you're still enjoying that benefit of national defense, even though, you're not paying any taxes towards it, so on and so forth, right? Same thing with, air, right? We can't stop people from breathing the air. So now that we have these definitions, now we can really start talking about the different types of goods. So let's get back into our notes. So this is 4, Roman numeral 4, public and private goods. And so private goods are both rival and excludable. They are produced in a competitive market system. And they are sold for a profit. Public goods are non-rival and non-excludable. public goods suffer from what's known as the free rider problem. Which is just that, when a consumer can enjoy the benefit of the good without having to pay for it. So, as a result of free riders, the government steps in to provide the good. Otherwise, there'll be an under-allocation. This is not going to prevent the free rider problems, but the government can finance the production through taxes, which we'll talk about towards the end of class today. Sometimes public goods can be subsidized through private related goods. Private related goods, therefore, being provided by private firms. So let's take a look here. It's always when I don't bring my book that I'm like, oh, I need that chart from the book. 1 second. All right, let's do applying the analysis on page 115. So we're going to use cost-benefit analysis to decide whether to provide a public good and how much to provide. So for this particular example, we're going to be comparing marginal costs and the marginal benefit of the project and seeing Where is it less than? Where is it greater than? So we're told the federal government is contemplating a highway construction plan. Now, the resources economies are limited, so any decision is going to use more resources in the public sector, which means fewer resources for the private sector. So there's a cost and a benefit that we have. The cost is the loss of satisfaction resulting from the accompanying decline in the production of private goods. So there's less private goods out there. So as a result, you're going to have less enjoyment of your paycheck. The benefit is the extra satisfaction resulting from the output of more public goods, right? So better roads means fewer potholes. My friend in Omaha, actually, they were trying to sue the mayor because the potholes there were getting so bad that they were popping tires. That's how bad that they were getting, right? So this, public good, right? Do we want to make our roads better? It does end up having an impact on our individual mileage and the cost of maintaining our cars, so on and so forth, right? And so we're going to use cost-benefit analysis to figure out, because most of the time we can't answer these questions with just a simple yes or no. We have to ask questions like how much or how little. So we are given table 5.2, 5-2, 5.2, whatever. And so we are given different variations of the construction project. So there's kind of what's called business as usual, which is no new construction. And this is going to have a total cost of what? 0. This is going to have a total benefit of what? 0. And so the net benefit which is just my benefit minus my total costs. Well, for this one, it's 0. It's going to be my green minus my red values. So the next one, we have option A, which is to widen the existing highways. And we're given a cost here of this is going to cost $4 billion. This is going to have a benefit of $5 billion. And so the net benefit here is going to be what? Oh, I just did a B instead of 5. And I did the wrong color. 5 billion, 4 billion. So it's going to be a net benefit of what? $1 billion. Positive, right? So when we have a positive net benefit, we're going to want to go ahead and do that thing. So then we have another gradation here, right? We're told, okay, we also have option B. We can build new 2-lane highways. This is going to cost $10 billion in terms of the cost of it, and also just the foregone cost of production, the foregone production of private goods, and the loss of enjoyment therein. But we're going to get a benefit of $13 billion when we get those newer roads. So that leaves a net benefit of what? $3 billion. So we would want to do that, right? That's actually more, that's a greater net benefit than the earlier plan. So then we want to go ahead and check out C, an even more expensive plan with a new 4-lane highway. The total cost here is going to be $18 billion. The net benefit here is going to be $23 billion. And so our total benefit here is $23 billion. So our net benefit is just the difference between our total benefit and the total cost. 23 billion minus 18 billion gives us positive 5 billion. And our last option that we're given D, which is just go all gung-ho, go get a new 6-lane highway. This is going to cause a lot of resources to be diverted from the private sector to the public sector. 28 billion. We're going to end up with $26 billion in benefit from the extra public goods. So at the end of the day, what's our net benefit? Our net benefit is going to be negative 2. So this is one way for us to figure it out, right? We use our incremental analysis. We say we start from this point right here. Do we want to go to A? Yes, because the net benefit, the marginal cost, so we have to have some extra little columns here, right? So we figured it out by just looking at the net benefit, right? But if we wanted to use our economics, which of course we do, we'd want to figure out the margin, right? The marginal cost and the marginal benefit. So the marginal cost of the first one is just 4 minus 0. It's equal to 4. Marginal cost of plan B is 10 minus 4 equal to 6. Marginal cost of C is 8. Marginal cost of D is 10. Marginal benefit of the first one, of A, is 5. 5 minus 0. Marginal benefit of the second one is 8. Marginal benefit of the third one is 10. And marginal benefit of the last one is 3. My brain derped there for a second. I was like, 13? How could that be? 3. So when we go ahead and when we analyze, okay, is the marginal benefit greater than the marginal cost? Yes, it is for this first one. We are going to want to at least do A. Then we ask ourselves, okay, are we going to want to do B? Well, the marginal benefit is 8, which is greater than the marginal cost. So yes, we're going to want to go ahead and do B as well. Are we going to want to do C? Well, when we go to C, the marginal benefit is 10, which is greater than 8. So yes, I'm going to want to go ahead and do C. Now, we're asked, do we want to do the last one? And we can see in 2 different ways that we don't, because the marginal cost is greater than 3, right? 10 is greater than 3, so you're not getting as much benefit as you're paying for that extra thing. And then also, we can just look at that net benefit too and make a determination based on that. So part of the issue is that it's not always very easy to figure out what the actual cost is of the diversion of resources from the private sector. There's a lot of estimation that happens there. There's so many related aspects, so it's really difficult to calculate. Nevertheless, the method is still very widely used. Questions on that? Just net benefit analysis. It's the same as the marginal benefit, marginal cost analysis. It's just a different way of doing it. All right, moving right along, we've got externalities. So I've already been talking about them, but let's go ahead and get some definitions in our notes. So externalities occur when part of the costs or benefits of one good affect or impact some third party that is external, there it is, that's where they get the name, externalities, external to the original market transaction. So, Negative externalities, we've already talked about how these are supply side. So we model them as such. So we have a demand curve, zoink. We've got a supply curve. And then we've got a socially optimal supply curve. When all of those costs, those extra costs, the cost of pollution, so on and so forth, when all those costs are taken into account. And so this distance between these two, that is the negative externality right there. Our market equilibrium gives us an allocation where there's a price right here and a quantity right here. But the socially optimal amount is actually up here. So the Q optimal, the price optimal. So this is what we call an over allocation. There's more being produced and sold at a cheaper price than is socially optimal. Why is that? Because there are costs that the supplier is not paying. If the supplier had to pay for those spillover costs, the marginal cost would be higher, and that's why the supply curve is shifted to the left. Just like when our factors of production, our input costs increase, right? When gasoline costs increase, when labor costs increases, that shifts the supply curve to the left. It's a similar thing. There are costs that they are not paying. If we made them pay them, that's where the supply curve would be. Questions on the over allocation associated with negative externalities? Cool. We're all following? Cool, cool. All right. We also have the corresponding graph for positive externalities, right? Doink. So with positive externalities, that's talking about there's a willingness to pay on all of the consumers that's not being reflected in the aggregate demand curve. So we have a demand that is encompassing all the willingness to pay. And since we aren't actually, since these are individual transactions that are happening and the individual person is just on the demand curve themselves, right? Because that's their individual willingness to pay. We end up with an equilibrium that is right here. And there is a underproduction of goods compared to the socially optimal amount. Questions on that? This is the under allocation. So yeah, so any kind of inoculations against communicable diseases. And so this is so funny. This is like a classic textbook thing. And it was like not controversial to teach 3 years ago, 4 years ago, 5 years ago, right? But now that like everything that's happened with COVID and stuff, right? Now it's like the room gets tense when I talk about it, right? But it's a classic in terms of there's positive benefits to everybody, to other people. If I'm inoculated, if you're inoculated, then there's less of a likelihood that other people around us are going to get the disease. And so there's a willingness to pay or a benefit. That's probably better rather than the willingness to pay, a benefit that everybody is getting. So the other people would be willing to pay some positive amount of money for the benefit that they would receive if some other person was vaccinated. But there's no way to make them pay, and so the only thing that we can do is we can have the government subsidize, and so they can, give people money to go ahead and make sure that they get the flu shot every year, or give people money so that they ensure that their lawns are beautiful, or whatever the case may be. All right. Which leads us to our next part of the notes. So how do we account for negative externalities or positive externalities, right? We've talked about this a lot, but let's get some notes on the matter. So, D. So direct government controls or taxes may be needed, nobody wants them, but it may be needed to reduce negative externalities or to provide subsidies, which are essentially the opposite of a tax. You give people money for things, or government provision. So it wasn't enough for the government to provide the vaccines for free. We should have given people subsidies, right? Where positive externalities exist. I think a lot of people that were on the fence would have not been on the fence if it would have been a $2,000, $3,000 cash payment as soon as you went in and got that second vaccine. I think a lot more people would have done it. See? And that might have been enough to just push you over the edge and to like, sure, why not? I'll get it, right? Like there was a lotto in Colorado, but that was dumb because everybody knows the lotto is not, it's like astronomical odds or whatever. But yeah, the whole thing was just mishandled. So what are direct controls? Direct controls are just what you think they are. They place limits on the amount of offensive activity that can occur. The most classic examples of this are, the clean water, not clean water and clean air legislations, forces offenders to incur costs associated with the pollution curve, which should shift the actual supply curve leftward, reducing equilibrium quantity. So the other thing that we can do, which is pretty much our go-to measure these days, is what's called a Piguvian tax. Now, it has nothing to do with pigs. It was discovered or created, whatever you want to say, by a guy, French guy named Pigou, P-I-G-O-U. So it just became known as Piguvian taxes afterwards. So, and they're a specific type of tax. We'll talk about it in a second. So they can be levied. Chevy to the levy, different kind of levy, on polluters. And so this Piguvian tax will be exactly equal to the size of the negative externality. And so, so when we have a negative externality, and when the government fixes it with direct controls, the government comes in and they're like, okay, so this Q, the equilibrium Q, that's where things are being produced, and we're just going to say that you can only produce this much. So a direct control would be they would set this amount. Terrible writing. Q direct control. They would just set that amount, and that would go ahead and shift their supply curves over. The other thing that they can do, so that's the direct controls, but like I said, most of the time we're doing a Piguvian tax, and so this is where they have the same setup. And they find how much is this amount here, right? What's the size of that negative externality? And that ends up how much they increase the taxes by. Exactly that size. Which does the same thing as the direct control. So they look the same in the graph, but they're different kinds of mechanisms. And so similarly, when it comes to positive externalities, help if I have the right thing open. So this is where it gets a little confusing. So we'll take our time here. So 3, subsidies and government provision suggest 3 options for correcting positive externalities. What are those 3 options? I'm glad you asked. So the first option, we'll go right here just for space. Buyers may be subsidized. So for example, new parents given coupons for vaccines at reduced prices. It would increase the number of vaccines. It would eliminate the underallocation of resources. So we'll go over what these look like in a second. The second option that we have is that we could subsidize the producers Gesundheit.
Thank you.
And we'll show how that looks as well. And the last one, which is what ended up happening, but it wasn't enough, is the government can provide the product as a public good. They should do this when the spillover benefits are extremely large. So, administering free vaccines to all children in India to end smallpox, which I think Bill Gates is doing, or did, is a case of that. So it's not just the government, it could be a nonprofit as well, right? So what does this look like? Because at the end of the day, economics is a graphical, diagrammatic science. And so as it is right now, this is the market demand. This is the socially optimal demand. The book calls it DT. I don't know why exactly they call it DT, but we're just going to use that. We have a upward sloping supply curve, ST. And we know that since we're not using the socially optimal demand curve and we're using the lower demand curve, that the equilibrium price is going to be here and the equilibrium quantity is going to be down here. There's going to be under allocation, right? We already did this one time. We're just doing it again because it's so much fun. So, correcting this via a subsidy to the buyers is literally just the same thing as the Piguvian tax, just backwards, just as it relates to demand. So we take that difference, whatever this difference is, between the socially optimal demand curve and the market demand curve, that's going to be called our positive externality. And then we're going to essentially give away that much money whenever anybody buys this. We're going to give it directly to the consumer in the form of a rebate or something, or a tax write-off, right? And so that's how we're going to correct if we are correcting on the demand side where the buyers are subsidized. Now we can also correct for the under allocation of resources via subsidy to producers. And these are all reproduced from your book, right? So if you need to look at them more, and they'll also be on YouTube as well. So this is our DT, that's our socially optimal. And so if it's the case that our supply curve is up here, we want to take the difference between that and whatever it's going to be to increase the quantity to whatever that socially optimal quantity is. So we take the difference here, and this is a subsidy to our producers. So that we can go from a Q equilibrium here to a Q optimal over here. So there's two ways to fix it. You're almost always going to see this way, but the other way is a way. It's a way. All right. Couple of things to wrap up, and then we can probably call it a day instead of starting chapter. I'll go ahead and I'll extend your chapter 6 quiz for an extra week since we didn't get to it today. Yeah, we should talk about this. So two last things to talk about. One, applying the analysis, and then talk about taxation. Yeah, I don't know if we'll get out of here early. Sorry that I teased you. Okay, so reducing greenhouse gases. So climate change, which is caused by human-generated gas emissions, is a classic negative externality problem. Some of the policies that reduce these greenhouse gases include carbon taxes, and cap and trade, which y'all might have heard of but probably don't understand, which is why we're going over it. So a carbon tax is rather simple in terms of it just increases the marginal cost of those greenhouse gases. As a result, whenever we increase the marginal cost, this is going to cause there to be a shift upward in the supply curve. And so if there's a constant demand curve, that's why we don't do upward, we do leftwards. So a carbon tax, I actually labeled this all backwards. Look at me. Demand is downward sloping, not supply. Burp, 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 burp. So demand is downward sloping. Supply is upward sloping. And we're going to have a shift to the left of supply, or a shift inward. And that's going to result in, we go from QE to QO. Anytime there's an increase in any kind of cost, that's going to cause the supply to shift leftwards. So there are costs and benefits to this, obviously. The revenue from the tax can be used to foster research in more renewable products. But this is really difficult for any kind of political will behind it. It's not politically palatable, right? It's very difficult for us to get anything like this passed because there's no such thing as a free lunch, which is our expression in economics that says that there's a cost to everything, right? So a 2007 study, and I haven't looked at this study, so I'm always very suspicious of studies until I take a look at them and their assumptions and how much it was reviewed and how many times it was done and, you know, so on and so forth. But it makes sense also that this would happen. A 2007 study found that a proposed $15 tax per ton of carbon emitted would raise the price of all fuels. So it would raise the price of gas, of electricity, of coal, of oil. Do you guys know that there's a coal train that leaves from South Dakota to Atlanta every single day to power the whole city of Atlanta? So when you're driving and you see that coal, that's what that coal train's going. It's going to power Atlanta. Isn't that wild? Random things I learned. So the effect of a cap and trade program So what is cap and trade? So cap and trade is where the federal government places a cap, that's where the cap comes from, on the amount of gas emissions and either gives away emission rights or auctions them off. There are costs and benefits to each one of these policies. You know, the benefit of just a flat tax is there's not a lot of government interference once it's put into place. The benefit to the cap and trade program is that you can actually lower the gas emissions, whereas if you just put a tax on it, people might just still emit the same amount and just pay the extra fee. But also the success of the cap and trade program has been very mixed because, again, you have a lot of people that are still paying, they're just paying more to pollute as much as they were. So the actual reduction in pollution hasn't really been seen from the cap and trade program. And also it requires a large amount of enforcement of the rules and government oversight, so on and so forth. Now, an important point to consider in the middle of all this that students often incorrectly assume, and so this book has a point all of itself for it, which I appreciate. It talks about how society's optimal amount of pollution, optimal amount of any kind of externality reduction is not necessarily total elimination. So in order to find the correct amount of pollution, which sounds really odd when we think about it, right? But there is such a thing in economics land. It's necessary to find the point where the marginal cost of cleaning it up equals the marginal benefit of clean air, cleaner air. So at the end of the day, how do we do all this stuff? Taxation. So taxes are a necessary evil. They are necessary to provide public goods, but of course they're controversial. Who wants to give some of their paycheck to Uncle Scam? Nobody, right? So there's been a lot of research into what's called the tax burden, which is the size, distribution, and impact of total costs that taxes impose on society. So we've got a couple of different ways to think about taxations. There's benefits received versus an ability to pay principle of taxation. So the benefits received states that, households and businesses should be taxed in accordance to the services that they get. That households and businesses receive. Oops, sorry, too much. So, gasoline taxes are earmarked for highway construction and for maintenance. But it's very difficult for the government to determine which citizens receive how much of the benefit from less divisible goods like national defense. Like clean air, right? And the other problem with this is that our current government efforts to redistribute income would be self-defeating. The welfare recipients would have to pay for their own welfare in an extreme version of this, right? So it just doesn't really work. So compare this to our ability to pay notion of taxation, which states that the tax burden should rest more heavily on those with greater income and wealth. Rationale is that those people with greater income and wealth are going to value their marginal dollars less than those with lower income. Also, the people with higher incomes spend less in terms of their fraction of their income. And so if you give more tax breaks to people at the lower incomes, then there's going to be greater demand for goods just in general. So giving tax cuts to the wealthy doesn't stimulate the economy in the same way that giving tax cuts to the lower and middle class does, because oftentimes the wealthy takes the tax cuts and they just put them in their, their retirement savings or whatever the case may be, right? They're not actually stimulating any economic activity when that happens. All right, so we will pick up here about progressive, aggressive. Don't go anywhere. I got to take attendance real quick. So we'll pick up here in class on Tuesday.